My name is Gabriel Henderson, and this is my teammates John, Malik, JP, and Freddie, and we are Team 6 for Senior Design, the ECE department, and our team is the EOD Training Tool. We did this in partnership with the U.S. Army Special Operations Explosive Ordnance Disposal, and we created a training tool for the Special Operations soldiers to be able to get real-time feedback based on what they're doing to try to get into an explosive package. So we have 4 sensors, an IR camera, photodiodes, photoresistors, motion sensors, basically anything that might potentially cause a package to go off, we have something to detect it.
So this is the user interface for the training tool. The first thing they're going to do is type their name in. So I'll put my name in. They'll then type what tool they're using. In this case we're using a drill. And the material we're using is a tile. The problems we're having is overloading 4 sensors. And so when they're too loose, it'll be yellow. When they're just right, they'll be green. And when they're too tight, they'll be red. Now it's yellow, so now we're going to go ahead and install the barrier material.
This is there.
Now they're all green. We'll hit the next button. And this will show all the graphs for the sensors we have. So we have accelerometer, a temperature sensor, sound, force, all those kind of sensors, and an IR camera. And so now we're going to drill through the box how they're going to do it, and the goal is to not go over these threshold lines and also not set up any of the LEDs.
So some of the design challenges that we had were that the sensor data rate was low, so the way to fix this was that we had to get better sensors basically. We also had connecting with unknown networks problem, where basically we just go into the Pi and we're able to change the settings there to include the network that we want. We had consistent data output that was with the input we wanted that, but it wasn't happening, so this worked out with both when we uploaded to the server and as well as the sensors that we upgraded. So both of these working in tandem got us the better connection. And then for usability, we wanted a quick change of the barrier material that's on the front of the box. We were able to do this by designing clamps instead of the full drill and putting in the material, gluing it in, all that. The clamps are way easier. You just unscrew them, put in the bearing material, and you're set for the next step.
Okay, so now once you finish that, you can stop and export a CSV file. And the CSV file will have all the data that we just collected. And so all this data that we just collected is in a CSV file, so the operators can see the exact data at certain time intervals and how they're performing. So yeah, that's basically everything with the box.
Freddie was the sensor lead, JP was connectivity, Malik was the microcontroller, John was the user interface, and I did the power system. We're all extremely proud of this box. We spent lots of time, lots of energy, and I think we're very happy with how it turned out.